Hello everyone. Welcome to the solution of LeetCode problem 904 named Fruit into Baskets. In this problem, you are visiting a farm that has a single row of fruit trees arranged in left to right. Now, the trees are represented by integer array fruits, where fruits of I is the type of fruit the ith tree produces. Now, you want to collect as much fruit as possible. However, the owner has some strict restriction, and the rules are you only have 2 baskets, and each basket can only hold a single type of fruit. That means in one basket, you cannot put multiple types of fruit, and there is no limit on the amount of fruit each basket can hold. Now, starting from any trees of your choice, you must pick exactly one fruit from every tree. This is important, including the start tree, while moving to the right. And the picked fruit must be fit in one of your basket. Once you reached a tree with fruit that cannot fit in your basket, you must stop. Now, we are given an integer array fruits and we have to return the maximum number of fruits we can pick. So here, let's consider the first example. We have 3 trees, which is 1, 2, and 1. The first tree produced type of 1 fruit, and it is produced the type of 1 fruit, which is the third trees. And the second tree produced type of 2 fruit. So here we can put all of them into our 2 baskets. So the maximum amount of fruit is 3. And here in the second example, if we start picking the fruit from the second index 1, and we can pick this one, these two, and these two. So we will store these 2 fruits into one bag, and we will store this 1 fruit into another bag. So in total, there are 3 possible fruit we can take. Now in the third example, the fruits are 1, 2, 3, 2, and 2. So for this segment, if we start picking the fruit from this element 2, and we can put these 3 2s into one bag and these 3 into another bag. So in total, there are 4 fruit can be picked. So this is the problem statement. I hope you understand it. Now let's move on to the algorithm. Now, let's take this example to understand the algorithm. We have 5 trees. Here, the first tree produces the fruit of type 1. The second tree produces the fruit of type 2. Suppose the type of 1 fruit is a circle. Type of 2 fruit is a triangle. Type of 1 fruit is a circle. Type of 3 fruit, let's say it is a square. And type of 4 fruit, suppose it is a rectangle. Now, we have 2 baskets, right? So for the first basket, we can put these 2 square balls, this and this. And for the second basket, we can put this triangle fruit. So in total, we can see that there are 3 possible fruit we can take. But for this segment, if we want to take this square fruit, we cannot fit it in any of the basket because a basket can only hold one type of element. Now, the simplified problem statement is we have to find the longest subarray which has at most 2 distinct types of fruit. How this converted problem statement comes from? Now, suppose for the baskets, we can start picking fruit from here. Now, if we start picking fruit from here, For the first basket, we can store one of the circular food. And now we will shift to this position. And for another basket, we can store the triangular food. Now we have to shift the pointer here. We have to again store the circular food into the first basket. Now we have to shift again. Now here we cannot store the square fruit. So we have to break the algorithm. Now it can be possible that suppose we start picking the fruit from the Saget index and go to the right side. Or either we can start picking the fruit from the third index or going to the right side. So the reduce problem statement is we have to find the subarray or the maximum length subarray which has the at most two types of fruit. Now, how can we solve this problem? We can simply solve this problem by using the sliding window technique. So for the sliding window, let's take 2 pointers. Now we will take one pointer which is left, another pointer which is right, and both of them is pointing to the first element. And we can take another map here. Now this is the map. Okay, so we have to increase the frequency of right pointer by 1. So as we know that map store the value in the key value of pairs. So the key 1 which has the value 1. Now we have to keep shifting our right pointer to this. Now for this segment, we have to increase the frequency of 2 by 1. And we can check that our map has 2 elements right now. So now previously our subarray length was 1, where the both left and right pointer is pointing to the first element. Now our map or the subarray length is 2, which has the at most 2 types of fruit. Now we have to keep shifting the right element here. So the map is, or the segment is this. Now we have to increase the frequency of 1 by 2. So we have to again check either we have has 2 entries in the map or not. Yes, we have 2 entries. So the length will be 3, or the length of the subarray will be 3. Now let's shift our right pointer to this. Now here we have to increase the frequency of 3 by 1. And but wait, our map has 3 elements. That means we have 3 types of fruit so far. So now it is not possible according to the problem statement. So we have to shift the left pointer here. And by shifting left, we have to decrement the frequency of 1 by 1. So now the frequency of 1 will be here. So our segment is this. Now, unfortunately, it also has 3 elements. So again, we have to shift our left pointer to this. So the I or the 1 frequency will become 0. So if any of the frequency becomes 0, we have to simply erase it from the map. Now, our subarray is this 1 and 3, which has the length 2. Okay, so far so good. Now again, we have to shift our right pointer here. And our subarray will be 1, 3, and 4. So the frequency of 4 will be increased to 1. And it has 3 distinct elements, which is not possible. So we have to simply shift our left pointer to this. And by doing this algorithm repetitively, we will calculate the maximum length of the subarray which has the distinct amount of or the two types of fruit. So here, by shifting this left and right pointer to the right side until the right pointer reaches the last position, we will check what will be the maximum length we can get. So here the maximum length will be 3. So for this problem statement or for this example, the maximum length will be 3. So if we consider 1, 2, and 1, it will be the maximum subarray which has at most 2 distinct elements. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named total fruit, which has the fruits vector as a parameter. Now we are taking a map and some of the variable ij and result. Now we are running this loop till our j is less than the size of the fruit. So here, each iteration, we will increase the frequency of fruit of j into the map. Now, if our map size is less than or equal to 2, that means our current window can be a possible subarray. So we will calculate the result, which will be the maximum of result and j minus I plus 1. Otherwise, if the map size is greater than 2, that means we have to shift our left pointer. So we are decrementing the frequency of the left pointer into the map. And if the frequency becomes 0, we are erasing it also from the map and increase the left pointer. Finally, after checking these two conditions, we will increase the j pointer value. Finally, after completing the iteration, we will simply return the result. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.